Probably one of the best known concentration units is molarity, and you're going to see capital M as a concentration on lots of things. Basically, molarity is defined as the number of moles of solute per liter of solution, and it's abbreviated as capital M. So molarity is equal to moles of solute per liter of solution. So when we use molarity, again, molarity is either we're calculating a concentration or we're going to use that concentration as a conversion chart. So when you see a capital M, okay, always think in moles per liter, because when you're calculating, that's what you're going to be going for, the moles and the liters, because that's how you're going to get to molarity. So in this particular problem, you got 20 grams of sodium hydroxide in 250 milliliter solution. It wants to know what is the molarity of that. So you've got 20 grams of sodium hydroxide and you've got 250 milliliters of solution, sodium hydroxide solution, and you're going to have to get to moles per liter. So one thing you're going to have to know is how many moles is that of sodium hydroxide. All right, and if you recall, you're going to have to use your formula weight for that. You're going to go to your periodic table and see how many grams is sodium, oxygen, and hydrogen, add them together, and then that's how many grams per mole you have. You've got milliliters of solution, and so you're going to have to convert that to liters because you're trying to get moles over liters. So you convert your grams to moles by using the formula weight from your periodic table. So 20 grams of sodium hydroxide times 1 mole over 40 grams, because grams have to cancel, so grams have to be on the bottom, and that gives you 0.5 moles of sodium hydroxide. Then you got to convert your milliliters to liters, and you may have figured out by now, because we use milliliters and liters a lot, that you could just move that decimal place 3 places, right? And then that would tell you how many liters you have. But if you do it with dimensional analysis, you've got 250 milliliters times 1 liter over 1,000 milliliters, so that milliliters cancel, and you're left with 0.25 liters of solution. Once you have moles and liters, then all you do is you put moles over liters, because that's the definition of molarity, and when you divide 0.5 moles by 0.25 liters, you're going to get 2.0 molar. Okay, so the molarity is 2.0. That makes it a 2.0 molar solution. So molarity can be used as a conversion factor when you're given the concentration in molarity, and it relates the moles of solute to the volume of your solution, and so you can actually solve for one of those if you know what the concentration is. To calculate the moles of solute, then you can just rearrange that molarity equals moles of solute per liter of solution to moles, and then multiply both times liter. So molarity times liters equals moles. To calculate the volume, you do the same thing, rearrange, and you get volume equals moles divided by molarity. So you're using the same thing, M equals moles over liters, to just rearrange to solve for either one of those parameters. So what volume in milliliters of a 0.3 molar solution of glucose contains 0.025 moles of glucose? Alright, so you got 0.3 molar, and we know it's moles of glucose per liter of solution. You've got 0.025 moles of glucose, and we want to know what is the volume in liters. First thing you're going to do is you're going to look and you see I've got 0.025 moles, and I can divide that by the molarity, 0.3 moles over liters. Something to remember, if you're dividing by something that's under the division sign, it actually becomes something on the top. That's just a math thing. All right, so you end up with 0.083 liters of solution. If you want to know milliliters, then you're just going to say your 0.083 liters of solution times 1,000 milliliters per liter, so that liters cancel, and make sure you go the right way, right? Gives you 83 milliliters of solution.